A piece of copper of mass m1 equals to 300 gram with initial temperature T1 equals to 97 degrees Celsius is placed into a calorimeter in which the water of mass m2 equals to 100 gram is at temperature T2 equals to 7 degrees Celsius. Find the entropy increment of the system by the moment the temperature equalizes. The heat capacity of calorimeter itself is negligible or small. When the piece of copper at higher temperature T1 equals to T1 plus 273 Kelvin is kept in water at the lower temperature T2 equal to T2 plus 273 Kelvin. First half, all the temperature of the system comes to equilibrium. Let this be at temperature T. Heat lost by copper M1C1 into T1 minus T and heat gained by water M2 into C2 into T2 minus T1. This implies T equals to M1C1 T1 plus M2 C2 T2 divided by M1 into C1 plus M2 into C1. Now the entropy of copper decreases and that of water increases. Hence, del S1 equals to decrease in entropy of copper equals to integration dq by t equals to m1 c1 integration t1 to t dt by t equals to m1 c1 log t by t1, and delta S2 increase in entropy of water equals to integration dq by t equals to m2 into c2 into integration t2 to t dt by t equals to m2 c2 m2 into c2 log t by t1. Hence, total entropy change del S equals to del S2 minus del S1 equals to m2 into c2 into log t2 by t1 minus of under bracket minus m1 c1 into log t by t1. This implies del S equals to m2 into c2 into log t by t2 plus m1 into c1 into log t by t1, where C1 and C2 are the specific heat capacity of copper and water, respectively. Putting M1 equals to 3 gram, M2 equals to 100 gram, T1 is equal to 273 plus 90, 370 Kelvin, and T2 equals to 273 plus 7, 280 Kelvin. C1 equal to 0.39 joule per gram Kelvin, C2 is equal to 4.18 joule per Kelvin. We get del S is equal to 4.4 joule per Kelvin. Answer. Two identical thermally insulated vessels interconnected by a tube with a valve contain 1 mole of the same ideal gas each. The gas temperature in one vessel is equal to T1 and in other T2. The molar heat capacity of gas of constant volume equals Cv. The valve having been opened, the gas comes to a new equilibrium state. Find the entropy increment delta S of the gas. Demonstrate that delta S is greater than 0. Considering the fact that the total internal energy of the system remains same before and after mixing, let the equilibrium temperature be T after mixing the gases. Now, NCV into T1 minus T equals to NCV into T minus T2. Suppose T1 is greater than T2. This implies T equals to T1 plus T2 by 2, equation 1. Now, entropy change of first vessel's gas is delta S1 equals to integration dq by T equals to Cv into integration T1 to T dt by T. equals to Cv into log T by T1. Similarly, entropy change of second vessel gas delta S2 equals to integration dq by T equals to Cv into integration T2 to T by T dt by T equals to Cv log T by T1. Similarly, entropy change of second vessel gas delta S2 equals to integration dq by T equals to Cv into integration dt by T equals Cv into log T by T2. Hence, total entropy change delta S equals to delta S1 plus delta S2 equal to Cv log T by T1 plus Cv into log T by T2 equal to Cv into log under bracket T by T1 into T by T2 equal to Cv log T square by T1 into T2 equal to Cv log T1 plus T2 का whole square by 4 T1 T2 since T equals to T1 plus T2. Hence answer.